Hello and welcome back. So today we are going to discuss on a new unit, that is testing. So for testing, before going on to testing, we have to discuss on some points on software quality. So software quality can be defined as an effective software process applied in a manner that creates a useful product that provides measurable value for those who produce it and those who use it. So it is something which is applied in a manner that creates a useful product, okay, for both, benefiting for both the manufacturer and the customer, okay. Now the definition serves to emphasize three important points. That is, an effective software process establishes the infrastructure that supports any effort at building a high quality software product. A useful product delivers the content, functions, and features that the end user desires, but as important, it delivers these assets in a reliable, error-free way. And by adding value for both the producer and user of a software product, high-quality software provides benefits for the software organization and the end user community. So based on that, we have defined software quality as per two scientists. One is David Garvin, that suggests that quality should be considered by taking a multi-dimensional viewpoint that begins with an assessment of conformance and terminates with a transcendental aesthetic view. Aesthetic means which is a set of principles underlying in the work of a particular task. That is Garvin's quality dimensions. Okay. Now it's 8 dimensions. Garvin's quality it has 8 dimensions. That is performance quality, which means the software deliver all content, functions, and features that are specified as part of the requirements model in a way that provides value to the end user. Then we have feature quality. Does the software provide features that surprise and delight first time end users? Then reliability, which means the software deliver all features and capability without failure. And conformance, that means the software conform to local and external software standards that are relevant to the application. Then we have durability, which means the software should be maintained or corrected. Okay. And serviceability, which shows that the software be maintained or corrected in an acceptably short time period. Then we have aesthetics, which I have already mentioned, that is a set of principles underlying in the work of a particular task. Then we have perception, which is a way in which something is understood or visioned particularly. Okay. We have another software quality measure, that is McCall's quality factors, which is represented in a figure format. We have three aspects in that: product revision, product transition, and product operation. In product operation, we have correctness, which means the extent to which a program satisfies its specification and fulfills the customer's mission, objectives, etc. Under product operation, we have reliability, the extent to which a program can be expected to perform its intended function with required precision. Then we have efficiency, the amount of computing resources and code required by a program to perform its functions. We have integrity, which extends to which access to software or data by unauthorized persons can be controlled. And we have usability, that is the effort required to learn, operate, prepare, input for, and interpret output of a program. Under product revision, we have maintainability, that is the effort required to locate and fix an error in a program. And we have flexibility, effort required to modify an operational program. And also testability, that is the effort required to test a program to ensure that it performs its intended function. Under product transition, we have portability, which is the effort required to transfer the program from one network or software system environment to another. We have reusability, that is the extent to which a program can be reused, program code can be reused. And interoperability, which is the effort required to couple one system to another. So this is McCall's quality factors. Now we have the software quality dilemma. Dilemma means it is a situation in which a difficult choice has to be made between alternatives. That is, the right decision or the right choice at the right time. Okay, so first factor in software quality dilemma is good enough software. So good enough software delivers high quality functions and features that users desire, but at the same time it delivers other more obscure or specialized function and features that contain non-bugs. See, while delivering high quality and functions or features, we have to make sure that these high quality software can at the same time contain non-bugs also. So choosing a situation which is a difficult choice, that is, we have to choose for a high quality software, but at the same time we'll be encountering with bugs also. So the software vendor hopes that the vast majority of end users will overlook the bugs because they are so happy with other application functionality. The software vendor thinks like that, but sometimes if it is a major or a good finite or a fine company or an organization, they may sometimes look into the bugs also. So the next software quality dilemma is the cost of quality. Cost of quality includes all costs incurred in the pursuit of quality or in performing quality related activities and the downstream costs of lack of quality. So to understand these costs, an organization must collect metrics to provide a baseline for the current cost of quality, identify opportunities for reducing these costs, and provide a normalized basis of comparison. So here we can divide the cost of quality into prevention, appraisal, and failure. Prevention costs include the cost of management activities required to plan and coordinate all quality control and quality assurance activities, and the cost of added technical activities to develop complete requirements and design models, and test planning costs, and the cost of all training associated with these activities. So all these can be controlled under the prevention cost. Our next one is the appraisal cost, which include activities to gain insight into product condition the first time through each process. So examples of appraisal cost include cost of conducting technical reviews, then cost of data collection and metrics evaluation, and cost of testing and debugging. Then we have the failure cost, which would appear if no errors appeared before or after shipping a product to customers. So failure cost may be subdivided into internal failure cost and external failure cost, where internal failure cost are incurred when you detect an error in a product prior to shipment. Before shipment, if we encounter an error, that is known as internal failure cost. So these include costs required to perform a repair to correct an error, or cost that occurs when rework inadvertently generates side effects that must be mitigated. Okay, see, when we rework on it, there may be some side effects which affects the software. Okay, then associated with the collection of quality metrics that allow an organization to assess the modes of failure. Then we have external failure costs that are associated with defects found after the product has been shipped to the customer. These include complaint resolution, product return and replacement, helpline support, labor cost, then associated with the warranty work. All these things comes under external failure cost because it comes after shipping the product to the customer. Now, next point in software quality dilemma is risks. So low quality software increases the risk for both the developer and the end user. Okay. Then next software quality dilemma is negligence and liability. The customer claims that the developer has been negligent and is therefore not entitled to payment. And sometimes the developer often claims that the customer has repeatedly changed its requirements and subverted the development partnership in other ways. So in every case, the quality of the delivered system comes into question. So we have to make sure on these dilemmas. Okay. And our next software quality dilemma is quality and security. So to build a secure system, you must focus on quality, and that focus must begin during the design itself. So as each project task is initiated, a project leader will make decisions that can have a significant impact on product quality. So we can make decisions based on estimation decisions can be done, scheduling decisions can be done, and risk-oriented decisions can be early done so that we can avoid all these dilemmas further. Okay, this is the impact of management action. Then how we can achieve software quality. Okay, it is a result of good project management and solid software engineering practice. So, management and practice are applied within the context of four broad activities, that is, software engineering methods, project management techniques, quality control actions, and software quality assurance. So, here the first point, that is software engineering methods. We can say that if we expect to build a high quality software, we must understand the problem to be solved. So we must also be capable of creating a design that conforms to the problem, while at the same time exhibiting characteristics that lead to software that exhibits the quality dimensions and factors. So we have to engineer such kinds of methods which we can expect to build high quality software, and at the same time we can solve the problem very easily. So many methods have been earlierly discussed in the earlier units. Then we have project management techniques. The impact of poor management decisions on software quality implies that if a project manager uses estimation to verify that delivery dates are achievable, that is very wrong. It should not be estimated, it should be finely calculated. Then schedule dependencies are understood and the team resists the temptation to use shortcuts. While we are dependent on schedules, we will be we will be resisted to use or tempted to use shortcuts for achieving the schedules. Then risk planning is conducted so problems do not breed chaos. Software quality will be affected in a positive manner. Okay, so we have to first of all plan the risks which we will be encountering while developing the software. Then we have quality control, which means quality control encompasses a set of software engineering actions that help to ensure that each work product meets its quality goals. So here models are reviewed to ensure that they are complete and consistent, and code may be inspected in order to uncover and correct errors before testing commences. We have the next one. A series of testing steps is applied to uncover errors in processing logic, data manipulation, and interface communication to achieve the quality. And a combination of measurement and feedback allows the software team to tune the process when any of these work products fail to meet quality goals. Our next one is quality assurance. Quality assurance establishes the infrastructure that supports solid software engineering methods, rational project management, and quality control actions. Suppose all these are applicable only if you are trying to build a high quality software. In addition, quality assurance consists of a set of auditing and reporting functions that assess the effectiveness and completeness of quality control actions. The goal of quality assurance is to provide management and technical staff with the data necessary to be informed about product quality, thereby gaining insight and confidence that actions to achieve product quality are working always. So I hope today's topic was understandable. It's just an introduction of testing, that we are first of all ensuring quality of a software in testing. Thank you so much.